Riemann Zeta function is defined as zeta of x, which is the summation of 1 divided by n to power x, and starts from 1, goes to infinity. You can list some of the terms of this series as 1 divided by 1 to the x plus 1 divided by 2 to the x plus 1 divided by 3 to the x, 1 divided by 4 to the x, plus the rest of the terms. This guy is used in number theory to analyze and the distribution of prime numbers. It has a use in series as well. It happens that the zeta of 2, which is basically the summation of 1 divided by n to power 2, n starts from 1 to infinity, that you learned as a p series. P is equal to 2, more than 1, so you get a convergent series, is basically converging to pi squared divided by 6. If it's easier for you, you can memorize this power series summation as well. What is the use of zeta of 2, or this p series when p is equal to 2, and it is a convergent series, and the sum of the terms of this series becomes pi squared divided by 6. So what does it tell us? It tells us, hey, if I start adding 1 over 1 squared, 1 over 2 squared, 1 over 3 squared, 1 over 4 squared, plus the rest of the terms, it becomes pi squared divided by 6. That's a common mistake that students think that, hey, this is the same as the integral of 1 divided by x squared, which is not. So let me write this guy as a common mistake for students. So on the exam, we ask, what is the sum of 1 divided by n squared? N starts from 1, goes to infinity, and students write based on integral test. Since the function f of x equals to 1 over x squared is positive, continuous, and decreasing, by applying the integral test, the integral of dx divided by x squared, x starts from 1, goes to infinity, is equal to, it's basically negative 1 over x. X starts from 1 to infinity, which is negative 1 over infinity minus negative 1 over 1, or 0 plus 1. So since the integral goes to 1, the summation goes to 1 as well. So since the integral of 1 to infinity of dx divided by x squared is equal to 1, it means that the summation of 1 divided by n squared, n starts from 1 to infinity, is equal to 1 as well. It is a mistake, everyone. Integral tests help you to analyze the behavior, convergence, and divergence of a series. It doesn't give you the summation. Based on the zeta function, zeta of 2 is the summation of 1 over n squared, which is pi squared divided by 6. If you add 1 over 1 plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared plus so on, you get pi squared divided by 6, which indeed is not 1. So we're going to use this zeta of 2 and calculate some other sums. The question says, find the following sum. We want to know what is the summation of 1 divided by n squared if I start from 2, go to infinity. Well, let me break this guy down into smaller pieces. This guy says, hey, I have 1 divided by 2 squared plus 1 divided by 3 squared plus 1 divided by 4 squared plus the rest of the terms. If I go back to my zeta function, my zeta function is 1 divided by 1 squared plus 1 divided by 2 squared plus 1 divided by 3 squared plus 1 divided by 4 squared plus the rest of the terms. To correct this, to make it more readable. So if you had 1, in your summation, you could say that, hey, I already know the value. So what I'm going to do, I'm going to compare this summation, which is pi squared over 6, and this summation together. What is missing here? 1 is missing. So you can rewrite this as 1 minus 1 and use this and zeta of 2 and do the calculation. Very easy. We know that this summation is nothing but pi squared over 6. So just substitute it over here. This is -1 plus pi squared divided by 6. So you can write the summation of 1 divided by n squared, n starts from 2 to infinity, is nothing but pi squared over 6 minus 1, and you are done. The next sum using Riemann Zeta function is find the sum of the summation of 1 divided by n plus 1 to power 2, n starts from 3, goes to infinity. Okay, so I'm trying my best to find any resemblance between zeta of 2 and this sum here. Okay. We try to find some similarity between zeta of 2 and this sum. What I'm going to do, I'm going to list some of the terms of this series and use dummy variables to shift the series. This series as the summation of 1 divided by n plus 1 to power 2, n starts from 3 to infinity, can be written as 1 divided by, if I plug in 3, I get 4 squared. If I plug in 4, I get 5 squared, and so on. Okay. If I look at my zeta of 2, I see the very first 3 terms are not here. Okay, very good. It's not that difficult to see that. We can add, subtract some terms and calculate this series. Let us add, subtract the missing terms. So this guy can be written also as, you have 1 minus 1, and then the next term is 1 over 2 to the second power. So you're going to add 2 to the 1 divided by 2 to the second. Also 1 divided by 3 to the second is missing. That's 1 divided by 3 to the second. And then just copy down the rest of the terms here. Plus 1 over 4 squared plus 1 over 5 squared plus the rest of the terms. Rearrange these so you can see the similarity between these two. You have -1 minus 1 over 2 squared minus 1 divided by 3 squared plus 1 plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared plus 1 over 5 squared plus the rest of the terms. So this guy here, this summation here, is nothing but zeta 2, which is pi squared divided by 6. We're going to use this guy just right here. Copy down the rest of the terms that we had to add and subtract. So you get -1 minus a fourth minus 1 over 9 plus pi squared divided by 6. So this number can be written as, if you take common denominator between these two, 36, -36 minus 9 minus 4 plus pi squared over 6 is equal to -49 divided by 36 plus pi squared over 6, or you end up with pi squared over 6 minus 49 over 36 as the sum of this series. So the summation of 1 divided by n plus 1 to power 2, n starts from 3 to infinity, is equal to pi squared divided by 6 minus 49 over 36. You could also introduce a dummy variable and rewrite this series in a different form. So quick note for you. We could also introduce dummy variable and rewrite the series as below. So here you have the series of 1 divided by n plus 1 to power 2. N starts from 3, goes to infinity. Wherever I see n plus 1, I'm going to use a new variable like k. So let k be n plus 1, right? So wherever you see n, you're going to use k minus 1. So this guy can be written as the summation of 1 divided by, so far, k squared, all right? But where does my k start? When n is equal to 3, my k becomes 4. So your k starts from 4, goes to infinity. Now you can relabel it. Relabel the index and the series. What do I mean by that? It means that wherever you see k, use n. So this series in terms can be written as, let me use a different color, the summation of 1 divided by n squared, and n starts from 4, goes to infinity. Remember that when you're working with series, you are basically looking at the large sums. These labeling, these letters, they're basically just representing what you have. If you write this series You get 1 divided by 4 squared plus 1 divided by 5 squared plus 1 divided by 6 squared plus the rest of the terms, which is basically the same as what you did up here. You plug in values for your n starting at 3, and you get 1 over 4 squared plus 1 over 5 to the second plus the rest of the terms. But if you use relabeling using dummy variables, you can basically rewrite your series into the summation of 1 divided by n squared. Now n starts from 4, goes to infinity. This is very useful when you're combining series together. So this method is very useful in ODE and combining series to find a power series solution for a differential equation. So let me recap what we did. We introduced Riemann Zeta function. Zeta of x is defined as 1 over n to the x and starts from 1 goes to infinity, which is 1 over 1 to the x plus 1 over 2 to the x plus 1 over 3 to the x plus 1 over 4 to the x plus so on. And zeta of 2 is the summation of 1 divided by n squared, which is basically a p-series. When p is equal to 2, which is more than 1, you get a convergent series. The sum of this series is pi squared divided by 6. Also, you can write the terms of this series: 1 plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared is equal to pi squared divided by 6. We use zeta 2 to calculate other sums. Like in this case, if the question says find the sum of the series 1 divided by n plus 1 to the second power, n starts from 3 to infinity, you're basically calculating the rest of the portions of this zeta of 2. It has some missing terms. What are the missing terms? 1 over 1 squared, 1 plus 1 over 2 squared, plus 1 over 3 squared are missing. So you're basically adding and subtracting these numbers to this series and then group these together. The group of these numbers is pi squared over 6 based on zeta 2. So when we did the algebra, we saw that the summation of 1 over n plus 1 squared, n starts from 3 to infinity, is pi squared over 6 minus 49 over 36. You could also use dummy variables and change the index, rewrite the series, shifting the index. What I did here, wherever I saw n plus 1, I used a new variable k. So since n starts at 3, my k starts at 4, just simple substitution. So the series can be written as the summation of 1 over k squared. K starts at 4 to infinity, which is using relabeling, we shifted the index, and the series can be written as the summation of 1 over n squared. N starts from 1 to infinity, and basically you get the exact same terms, but now you shifted the index, and here you have a shapeshifter series. This is very helpful in differential equation, finding the series solution for a differential equation.